Stoichiometry
and how it's used in the modern day world.
by Lexie
And Kaylee.
for Miss Garcia's honors chemistry class.
And Miss Avari too. Hey guys, we're here to talk about the two C's today, cookies and camels. What do cookies have to do with camels? Well, they both use stoichiometry. What's stoichiometry? Well, it's this weird mathematical formula that literally allows us to determine how much substance is consumed and produced by a chemical reaction. The first thing that you have to do when you do a stoichiometry problem is balance the equations, which means to make sure that there's the same amount of atoms on each side, because the problem won't work unless you have a balanced chemical equation.
Let's start out with the equation nitrogen 2 plus hydrogen 2 equals ammonium. Now this equation isn't balanced the way it is. We need to get this equation balanced, and what it looks like when it's balanced is like this.
The first step to balance an equation is to evaluate all of the elements and how many there are. We will start off with hydrogen.
Let's start off with hydrogen. Hydrogen has 2 atoms on the left and 3 on the right. So to get them balanced out, you have to add a coefficient of 3 to hydrogen on the left and a 2 on the right. Coefficients always go in front of the symbol. They never go on the bottom. Those are called subscripts. You cannot mess with those when you're balancing your equation. By balancing our hydrogen, we are also balancing our nitrogen to where there is 2 on both sides, and now there are 6 hydrogens on both sides as well. And therefore our equation is now balanced, and we can now solve the problem that we have. Let's think of this equation as a recipe. All your compounds and elements are your ingredients, and what you end up with at the end, your products, is like a cake or a cookie. Now if you don't have enough eggs, then you can't make 2 batches of cookies, even if you have plenty of chocolate chips for them. In chemistry terms, the eggs would be the limiting factor, and the chocolate chips would be the excess factor. The limiting reactor is a fancy name for the substances that runs out when the chemical equation is done. It basically sets the tone of how many of your product can be made. The excess factor is simply what is left over when the reaction is over with. What's, well, excess.
Molar mass adding. Don't forget the coefficients and subscripts. An example would be H2O, and you have to take the atomic mass of hydrogen and oxygen and add it together, but you can't forget the coefficients because they're important. And when you go through all the math and everything, you get about 18.02. Now you have to multiply the hydrogen's atomic mass by 2 and then add that to oxygen's atomic mass, which got you the 18.02 number.
But we know the basics, the very basics. Let's try one out. Here's our problem. 3 magnesium chloride plus 2 sodium phosphates equals 6 sodium chlorides and magnesium phosphate. Okay, so assume that we have 0.75 grams of magnesium chloride, which is right here, and 0.65 grams of sodium phosphate are placed in a reaction vessel. How many moles of sodium chloride will be produced? To start off with, we're going to put 0.75 grams of magnesium chloride in the top part of the bracket. And because we're trying to get to sodium chloride moles, we're going to have to convert this to moles to begin with. So we are going to put the total molar mass of magnesium chloride in the bottom part of the bracket to cancel out in the grams. So we're going to put 95.2 grams of magnesium chloride there. And then we're going to put 1 mole on top to cancel it out of magnesium chloride. Next, we're going to take the molar ratio of the 2 substances in the next bracket. And because we have magnesium chloride on the top, we have to put it on the bottom again to cancel out, just like we did here with the moles and the grams. So we're going to put 3 moles, and we're getting our mole ratio from the coefficients up here. So we're going to get 1 from here and another 1 from there. So we're going to have 3 moles, my bad, of magnesium chloride on the bottom, And then because we're looking for sodium chloride, we're going to put 6 moles of sodium chloride on the top. Just like that. Only need to find the moles. We're going to stop right here and we're going to ignore that because that never happened. So I'm going to put these into my calculator. 0.75 times 6 divided by 95.2 divided by 3. And then our answer is going to be 0.015 moles of sodium chloride.
Now let's try solving one that finds percent yield. So this is a worked out problem of a percent yield equation, and it gives you some of the numbers and it doesn't give you some of the numbers. The first thing you had to do is balance the equation, and I've already done that for us. I've actually already done all of it, but that's besides the point. And so what's going on here is that they gave us this number, the 87.5 grams of CaNO3 parentheses 2. And that's what they give you to that's like the starting reactant thing. And then you have to find the molar mass, like we talked about earlier, and put it here, because the grams have to go across. And so that the 164.1 is the molar mass of this. And that's equal to 1 mole through 1 mole of the same substance. And then you have to use the ratio, which is, since there's no number here, there's an implied 1. That's the first part of the ratio, so that goes on the bottom. And then since you're trying to find calcium, what's that part? Carbonate, we believe. Since we're trying to find calcium carbonate, this is the second part of the ratio. So it's a 2, which is right here. That thing. And then you have to, then that gets put into 1 mole of the calcium carbonate, and you have to find, again, the molar mass of it, which is the 55.08, which gives you this, the grams of the calcium carbonate produced. Now this is the theoretical, this is what we've done. But in the problem, it gives us 46.8 grams. And they give that to us in the problem, so that's the actual. So how you do this really is the actual yield over the theoretical yield times 100, and that equals the percent. So you divide the 56.8 by the 58.74, and then you multiply it by 100, and that gives you 79.67% of calcium carbonate.
The equation for what happens during this chemical reaction looks like this. Actual stoichiometry part of it starts off like this.
It's this really long equation that takes a lot of time.
That's our project on stoichiometry and how it's used in everyday life and how to work out a stoichiometry problem. We hope you learned a little,
Just a smidge.
maybe a lot, or maybe nothing at all. But now
Maybe you know it on your genius.
But now you know more about camels, airbags, rocket fuel,
Cookies.
and cookies. Thank you for watching.
Later, guys.
Bye.
You know, I don't even like carrots.
Okay, chemistry.